Autophagy is the body's microscopic version of a luxury cleaning service, the sort that doesn't just sweep up dust but recycles broken furniture, damaged machinery, and leftover confetti into useful new materials. In the cellular world, lysosomes and proteasomes are the ultimate multitaskers, turning chaos into order without complaint. And here's where the paradox gets deliciously ironic. Autophagy runs most efficiently when you're fasting, meaning the moment breakfast enters the equation, the janitorial team reluctantly sets down its brooms. The eggs, toast, coffee, or smoothie you consume are like a polite but insistent guest saying, "Excuse me, can we interrupt this cleaning? Energy first, please." Your cells sigh, glance at the clock, and mutter, "Fine, cleaning can wait until later." Animal studies, particularly in rodents and nematodes, have shown that periods of fasting or calorie restriction activate autophagy in ways that are strongly associated with increased lifespan. In simpler terms, giving your cells a scheduled cleaning period helps them stay youthful, efficient, and resilient. Autophagy clears out molecular trash, improves mitochondrial function, and reduces oxidative stress, all factors linked to longevity. It's as if skipping breakfast or extending fasting periods in these studies allowed the microscopic janitors to throw a multi-hour spring cleaning party, sweeping away the molecular equivalent of decades of clutter, leaving the organism in better shape for longer. Some studies even suggest that intermittent fasting can delay age-related decline and improve resistance to chronic diseases. The logic seems straightforward: more autophagy, longer lifespan. But here's the human twist that makes this paradox funny and fascinating. Unlike lab animals that can thrive on a regimented fasting schedule without worrying about morning emails or cognitive demands, humans have energy needs that cannot be ignored. Our brains consume roughly 20% of daily calories, and waking life demands immediate fuel for thinking, moving, and managing the chaos of modern existence. Skipping breakfast may give autophagy a head start, but it can also temporarily compromise attention, mood, and alertness. In other words, your cells may be partying like it's 1999, while your neurons are grumbling, "Hello? A little glucose, please? I have deadlines." It's a quirky negotiation between longevity-focused cellular repair and real-world human functionality. Picture the scenario like a morning sitcom inside your body. Lysosomes are lined up, armed with tiny vacuum cleaners, ready to scrub misfolded proteins and recycle old organelles. Mitochondria are pumping motivational tunes through the cytoplasm, encouraging productivity. Then breakfast arrives. Insulin bursts onto the scene like a traffic cop waving fluorescent flags. "Hold up, everyone. Energy delivery is priority number one." The janitors groan, the mitochondria sigh, and neurons throw tiny protest signs reading, "We need fuel, stat." It's an intricate dance of biology, one in which long-term cellular maintenance and immediate cognitive needs hilariously collide. Humans, unlike lab animals, have the advantage of choice and context. We can delay breakfast to extend fasting windows and let autophagy work a few uninterrupted hours, or we can eat right away to fuel cognition, muscles, and metabolism. The key is balance. Research suggests that moderate time-restricted eating, for example, can harness some autophagy benefits while still providing adequate energy for morning performance. Unlike nematodes, humans must negotiate not only cellular repair but also energy for thinking, exercising, and navigating modern life. It's a sophisticated tug-of-war with no universal rule, only guidelines that can be personalized. The funny, positive spin is that this paradox makes our biology both clever and entertaining. Skipping breakfast occasionally is not a moral failing or a radical experiment. It's giving your cells a luxury cleaning session they might otherwise miss. Eating breakfast, meanwhile, is rewarding your brain, muscles, and metabolism, even if it temporarily pauses the cellular janitors. In the grand scheme, your body adapts. Autophagy will resume later, metabolism stays balanced, and cognitive function remains intact. You get the best of both worlds: longevity-focused cellular repair and immediate functional energy, just on slightly different schedules. Ultimately, the autophagy longevity paradox is less a dilemma and more a testament to human adaptability. Animal studies remind us that fasting can promote long-term cellular health and lifespan, while human energy demands and lifestyle factors emphasize the importance of morning fuel. The humor and elegance lie in this negotiation. Your lysosomes may be rolling their eyes, mitochondria tapping impatiently, neurons waving protest flags, and insulin bursting in like a comic relief character, yet the system works harmoniously. Skipping breakfast occasionally may give your cells a party. Eating it may fuel your day, and either way, your body cleverly balances repair, energy, and function, often with a wink of evolutionary humor.